Hey people, welcome back. And in this session, we are going to learn about the basics of regression analysis. So when we talk about the regression analysis, basically the meaning is to how we can predict the value based on the linear relationship between two variables. So example, if I say, suppose you have your input variable like this on the x-axis and your output variable is on the y-axis like this. And you have some data points. Basically, they are going in this direction. Up to here you have. So obviously, in the future relationship, if the data points will behave in the same way, so the next value probably may lead from this place to this place like this. So the blue one is your prediction, and suppose your green one was the actual data. So how to see these with help of the numbers statistically, how to predict the value based on the x and the y variable relationship is all about the statistics. Regression analysis. This regression analysis works on the equation y is equal to a plus bx, where the y variable is your output variable. X variable, you have your input variable. And based on the relationship between input and output, you will get the A, which is called as an intercept, and B as in slope, which is called as a gradient as well. Slope or gradient. So the definition of Y and X you already know. The intercept and slope for any regression analysis, intercept is what is the minimum value of Y is the starting point of Y variable when X variable is equal to 0 or constant, which means if you look at this equation, suppose I'm deleting. So here is your Y variable. Let's say here is the value 1, 2, 3, 4, 5, and this corner is 0. And similar way, you will go like 1, 2, 3, 4, 5. So here you can see that when X variable is 0, I'm keeping this X variable here 0, and the minimum value of the Y is coming somewhere here, which is around 3.5. So the area between x is equal to 0 and the starting point of y is your intercept. This gap is the intercept. What is the slope? Slope of a data is the rate of change when x changes in 1 unit, and what is the reflection or how much? Because of that, how much is the change in the y variable? That is your slope. Example, if this is your equation, suppose like is going like this. So if I see the x is changing by 1 unit, suppose from here to point number 3 here. We can see here. So it has moved from 2 to 3 unit, right? We can see here. Now, how much is the change because of that is reflecting in the y is what? Your slope. So how to find that slope? If I draw another line here from this place to the straight line here on the y-axis. This is the blue line you can see, and another blue line I will draw from here to here. Now you can clearly see on the y-axis, I have a space which is like this. So the gap between the upper and the lower line, if you see this blue here, this gap is your slope or the rate of change when the 1 unit change in the x here, 2 to 3, the change it is reflecting in the y here is your slope. These are the basic things about the regression analysis. Let's take an example when we are learning these basics. So suppose you have a x variable and y variable. Let's say my x variable, I'm talking about the newborn baby, and here is my y variable. So X variable is suppose age, baby born today. So it's a age is 0 days. Hmm, what happened here? Age is 0 days. Now age of the baby is 30 days. Let's say 60 days, 90 days, or maybe 120 days. Now the Y variable, when the baby born on the 0 day, obviously weight of the baby will not be 0 days. It will be some minimum value. Suppose on an average, the weight of the baby is around, let's say 2.82 kg. So now you can see what I was telling about the intercept. Age of the baby is 0 days and the minimum weight of the Y variable is 2.8. So here you see this gap up to 2.8. This is what is called slow intercept. This is what is called as an intercept. This gap between when X is equal to 0 and the Y variable is X value. So this is your intercept. Now, on an average, baby will gain around nearly 400 gram of weight. So suppose after 2.82 kg in the second month, the weight of the baby became after 30 days, let's say around maybe 3.11 kg, or let's say 3.11 kg. Then after 30 days, the weight of the baby another 30 days was around, let's say 3.57 kg. Maybe when the baby become 3 month, the weight of the baby was around, let's say 3.81. And then after 4 months, weight of the baby was around 4.22 kg, suppose. So this is what my data is. If you look the same thing in a graphical way, as I was explaining, so this is how the relationship is going between two variables. If I change this here to start from, let's say 2.5, then it will look better. So this is how the equation is going, and this should be interval of 30 days because we are talking about the 30 days data. So based on this equation, I can predict after 150 days, approximately in the same line, if this will go. So how much will be the weight of a baby when your X variable is changing by 1 unit? 1 unit means 1 month data you have in the X variable. Like this. Here I will find somewhere based on this straight line like this. Right, connecting the baseline. So here will be 150 days, weight will be here somewhere, and this will be more than 4.5 kg approximately. How to find that? So first let's see what is the correlation between these two. How strongly these values are correlated, or how strongly your X variable can explain the Y variable. So as a best practice, we select Y variable first, and then we select the X variable. Now, your X variable is able to explain the changes in the Y variable almost 99% accurately. This is what the correlation says at 95% confidence level. I have to find out how much is the intercept or slope. So basically this is your actual value. And as per this line, if you see, let me just delete this line and I will draw a trend line here. And trend line, I'm drawing a linear. So this, as per the trend line, when you see, how much is the value of your intercept? Almost at the same place, the adjusted value will also come. What we have the value, the same place, your adjusted value is coming almost there, right? So that will be your intercept. We can find the intercept with an Excel formula. If I put simply intercept, select your Y variable, select your X variable, and here is your intercept. 2.86. So actual value was 2.80, but the calculated value is 2.806. So 2.8 to 2.806. Little difference is there. What rate it is changing? So my X variable interval is on the month 0 to 30, 30 to 60. So 30 days to 60 days in between a 30 days of gap, which means the unit of measurement is 1 day. So every day, how much weight baby is gaining, because the equation is going positive. So baby is gaining a weight. So how much weight baby is gaining every one day, each day, we can find out with the help of slope as per this data. SLOPE, select your y variable and select your x variable. So baby approximately gaining 0.011 kg weight every day. And now putting these values into the equation y is equal to a plus bx, I can predict my value. Suppose now, let's continue with this equation. Based on this data, you have to find out value of y. Y means here, y is your weight. When baby will become how much? Let's say around 175 days. So how much weight approximately baby will have? If your age is 175 days, this is what you have to find out. So we have a equation y is equal to a plus bx. Value of a intercept I know, value of b slope I know, value of y I have to predict, and value of x I know. Simply you will put in this equation. So y is equal to value of a 2.806 plus value of b slope 0.01167 multiplied by value of x 175. So after 175 days, your baby will have approximately 4.84 kg of the weight. This is how we'll be calculating with the help of regression. Now, if we reverse the equation, suppose you are going to the doctor and doctor advise you to do the vaccination only when your value of X, which means baby, is 5 kg. Sorry, value of Y is your 5 kg. So you are looking for at what age my baby will become 5 kg. So the same equation y is equal to a plus bx, you will just transform it to the x is equal to. So this y is equal to a plus bx, if you transform the equation, so it will become x is equal to y minus a and divide by b as a mathematical transformation. Now you put the same value into this. So x is equal to y value is how much? 5 minus a intercept 2.806 and divide by b. B is your slope 0.011. And here we go. After 188 days, your baby will gain approximately 5 kg of weight. This is how do we do regression analysis or the simple regression in Excel. If the same thing you want to see in Minitab, let's learn now. Because there are few other things as well which you need to see in a simple regression. Now I want to run a regression analysis between these two variables, the same variable. So I'll go to the stat, regression, regression, and fit regression model. Click here. Your y variable is your column C2 and x variable is your column C1. That's all as of now. Click on OK. So now you have a equation available here. The same equation y is equal to a plus bx, which we have derived in the Excel. You can see here. What are the other thing you will see? We will see this coefficient table. The constant explain about the y variable. And if the p-value of the constant is less than 0.05, this means your y variable has a significant relationship with the x variable. Then we look for the x variable as well. If the p-value of x variable is less than 0.05, which means your x variable also have a significant relationship with the y variable. We got it now? Now, further, we will look for this graph. So if this is the threshold kind of thing which will be automatically calculated by Minitab, if your Input variable is crossing the line, this red line you see and the A line. That means the relationship is significant, which we have seen in the p-value as well. So this equation we can use for the prediction. Suppose you have more than one variable at a time. Or let's say based on this value only, as per the data, these are my actual value, and I want to find out what should be the predicted value, ideal condition. These are my actual. As per this, what should be predicted? So I can suggest that as well, and I can validate my equation. I'll go to the storage and I select the fits. That's all. You click on OK and you click on OK. So here are the fits value, which is your predicted value, automatically calculated by the Minitab. You wanted to see how well you have predicted against the actual. So simply go to the graph, go to the scatter plot. Let's select with group. Y variable is your new Y variable is your predicted one, and X variable you have your original Y variable, what was there. Against that we have selected, or maybe you can use the X variable both. Let's say first I am using this, then predicted and versus X. In multiple graph, you can say in separate panel of the same graph, and here is my relationship. Data view, all good. So now you can see the relationship between two. So against the X variable, obviously it will be straight line because based on that predicted, and against your Y variable, how the equation is going. So that gives you a confidence that how accurately the predicted value you have calculated in the Minitab. If you want to do the same thing on a large amount of data, suppose I pick up some data and here is your three variables. Let's say I will pick up these five variable here where the two are the categorical variable and three are your numerical variable. First, you wanted to see the relationship between, suppose maths is your Y variable and reading and the writing score is your X variable. So you want to see, does your math variable or the Y variable has a significant impact for any of your input variable? Answer is yes or no. We want to find out. So first we do the correlation you have learned in the last session, and this time we are going to run the regression. So we'll go to the stat, regression, regression and fit regression model here. Y variable is your maths score and you are looking from the reading and writing score. That's all. Just click on OK and here are the result. So you can see the equation math score is equal to Y is equal to A plus B1 X1. B1 is your slope for the reading score as an X1 and B2 is the slope for the writing score as an X2. All of these three p-value for the output variable as well as for the input variable is less than 0.05, which means my relationship is significant, or X variable is significantly impacting the Y variable, or Y variable has a significant impact for the X variable. But here is the another important thing you have to see, VIF, which stands for variation inflation factor. If the variation inflation factor is greater than 10, we assume this is significant. So meaning of variation inflation factor is your X variable probably impacting the Y variable. I understand that because the p-value is less than 0.05, but your X variable has a significant relationship with the another X variable. Like as here is the reading score has an impact on the math and your writing score has an impact on the math, but reading and writing score also correlated with each other significantly if the VIF is greater than 10. This relationship we will be reading here R square adjusted value because we have more than one input variable. So adjusted slope it will give. It is around 67% is the strength. Another important thing in the ANOVA table, we have to look for the lack of fit value. So the p value for the lack of fit is around 0.580. This signifies that data has no evidence of lack of fit, which means my data fits very well. In case your lack of fit p-value comes by any chance less than 0.05, which means data has a fitment issue in the equation. Maybe your p-values are less than 0.05, but still data may have a fitment issue if the p-value of lack of fit is less than 0.05. In the below table, you will see some of the R, which represent the large residual, which means data values is far from the expected. Example wise, your expectation is lying this. So some of the values are, they are lying away from the expected. Expected is center line and actual value is here in the fitment line. This is what the arch shows large residual, and X is significantly away values. X values, what you see, they are significantly away, which is we call as an unusual observation. Unusual observation means we are not expecting this, but something is happening wrong. Suppose you are expecting the values here, and let's say your large residuals are coming like this. They are away from the line, but some of the value will be extremely away. These are the unusual observation. They are away, much away from the large residual as well. Like as you can see here, your expectation value may be around fit value is 56, but actual value is 38, which means it's a away, it's a large residual. Same time, your expected value as per data is around 20 and actual value is coming as in 0. It's a large residual as well as unusual observation. This is the way we'll be seeing or reading this data. Now, further if we want to continue, maybe I wanted to predict based on, suppose, categorical variable as in test preparation. So, by test preparation completed or not completed, if I put the test preparation here, and then I wanted to check my regression analysis, then here I will see. Now I have the two equations, one is for the completed and another one is for the not completed. Y is equal to A plus B1 x1 plus B2 x2. Then Y is equal to, for the math score, B1 x1 plus B2 x2. You can see the p-values here. For the test preparation, none is less than 0.05. VIF is sometime greater than 10. And if I look for the lack of fit, it is perfect. P-value is greater than 0.05, which means my data fits very well. And here is the answer for the large residual as well as unusual observation. Now, based on this data, you wanted to predict how categorical variable has an impact. We have seen here, there is a significant and you want to store this value, go to the storage and just select from the fits. So the new Y variable will be selected and the stored here in the data. So here is the fits value, what you see is the new Y variable, which is your Y variable is this, but actually Y variable now adjusted values are coming this. This is your actual value. You want to see the relationship of fits with your another two input variable to validate your equation. We'll go to the graph, scatter plot. Let's say select this. Now you have the Y variable here is the fits. X variable is your reading score. Then Y variable is fits. X variable is your writing score. Multiple graph in separate panel of the same graph, or let's say on separate graph. And now you click on OK. And here is the graph. So this is how well your reading score is explaining the changes in the math. And the second graph which you see, how your writing score is explaining the changes in the maths. So the most concentrated data point you are getting in the reading score compared to the writing score, which means if you go with the reading score, score can explain or can predict the changes in the math score in a better way comparative to the writing score. And the predicted values are already stored here. So how to read this? Your math score actually was 72, but it should be 69.97 when your reading score is 72 and writing is 74 and test preparation not completed. Now, suppose your actual score is 69, math score, when reading is 90 and 88, but ideal condition, it should be 82. You can predict as an 82.5. When your writing score 88, reading score 90, and the test preparation is completed. This is what we'll be predicting. And the same thing you have seen in the graphics. These are the fundamentals of regression. Regression is not a topic, it's a subject. There is so many type of regression. In the part 2, I will be covering the more detail of the regression analysis. Thank you so much, people, and I'll see you in the next session.